Hi, welcome. In this video, we will solve problem permutations asked by companies like Amazon, Facebook, Google, ByteDance, Apple, Adobe, and Salesforce. Now let's solve one more problem on backtracking permutations. One of the very good problem around backtracking. If you want to understand your backtracking concepts on depth, okay, this problem is must to do. Okay, so let's understand this problem. So here given an array nums of distinct integers, return all the possible permutations. You can return the answer in any order. So what are the possible permutations? Here you can see in this example, its size. Here we have three elements, right? N is equals to 3. Okay. You can see this is one of the permutation. Basically, one of permutation means arrangement. That how you can arrange the number of elements, right? So number of arrangements they are asking. So one arrangement is this one, 1, 2, 3. One arrangement is 1, 3, 2. If I swap basically 2 and 3, right? And one arrangement is 2, 1, 3. Basically, if I swap 2 and 1, here it will be 2, 1, 3, then 2, 3, 1, then 3, 1, 2, and 3, 2. These are the all possible arrangements that can be done by three elements, right? So these are total 6, which is basically your 3 factorial, right? And so can I say for what will the number of permutations? The number of permutations will always be n factorial, that is n factorial. Okay. Now let's see how we will solve this problem. So here we have an array with three elements 1, 2, and 3, right? With its an index 0, 1, and 2. Okay. So what I will do, okay, what I will do, I need to take 1, okay, okay. Suppose I need to take 1, then I can take 2, and then I can take 3, okay. But suppose instead of not taking 1, right, I will start these things 2, right? Start with this 2, right? I am taking 2, right? So what I will do, I will take 2, and again what I will do, I will check, okay, that I have taken 2, that means this is done. So the remaining elements are left that I can take in, that is 1 and 3. So suppose if I am taking 1, I will take 1, right? So now this is also done. Now the only element is left, that is 3, so I will take this one. So you can see I am able to generate by picking 1 and not picking the second, right? Something like this. So you can see this is one of the arrangement, right? And this is also one of the arrangement. Okay. Suppose in the first I have picked this one and I consider that these are not to pick, right? So what I will do, I will check either I can take this 2 or this 3, right? So I have taken 2. Now the only element left, that is 3. So I have placed 3, right? Then in the next case, I have started with 2 first. Okay. Then I will check either I can take 1 or 3. So I have taken 1. Then I will check, okay, the last element will be filled with 3. Similarly, I can do one more thing, right? There are different possible ways, right? Suppose I have started with 3, right? So I will say, let's take first 3. Now the remaining elements are 1 and 2. So either I can take 1 or 2. Suppose I have taken 1. Okay. Now the only element left, that is 2. So I will fill with 2. So you can see here, basically, there is a loop, right? I am continuously choosing between the three elements. Okay, between the n elements, if there is n here, n is equals to 3 elements. I'm continuously choosing between the three elements, right? And once I have chosen, okay, once suppose I have chosen any element, okay, I can't take it again, right? I can't take it again, or I won't take it again. I will not take it again. That is the intuition behind this problem, right? I'm just choosing one element. Either I can take 1, then 2, then 3, right? Suppose if I have taken 1, so I am not going to take 1 again, right? Now I will take from either 2 and 3, right? Suppose if I am taking 2, I'm not going to take 2 again. I take 3, right? So let's try to solve it by considering all the possible arrangements, right? So what I will do, I will create one data structure. Okay, let's suppose that will be a list. So let me quickly put this array as the front here. Okay, let me remove this 3. Let me mark this 3 as this one. This is one. And let's see on a broader picture. Okay, so let's do it here. So I have in this an array. I will take an empty list. Okay, one by one. And because I need to check which I have taken, right? Remember, once I have chosen an element, right, I'm not going to take it again, right? So I will make one answer for that also. So I will take a map. So by suppose this an array, I will take this map. Basically, this will tell I have taken that element or not. Okay, so let me decrease its size. I hope this is equal, right? This is okay. So what I will do, suppose in the starting, right? Let's suppose I have map here, and in the starting, all these are false, right? I have not taken anyone. Okay. So what are the calls that I can do, right? What are the 3 calls I can do? Basically, I can either take 1, right? Or I can take 2, or I can take 2, or I can take 3, right? So let's see. If I am taking 1, right? It will be in the first 1. Okay. I am taking with the 1. Okay. Now I have taken 1. Okay. Let me put this thing so that this will can start with something and you will get a bit of idea. Let me copy this one too. So the one will come for this, one will come for this, one will. So, okay, here I have taken pick the 0th index element, right? 0th index element. Okay, here I have picked the first index. Okay, here I picked the second index. So here I have picked the first, I have pushed it. Okay, basically what I will do, I will push it. So I will push 1. Right? This is an empty array. This is my array. Okay, this is my array. This is array. Okay, this is the given array. This is the given array. So what I will do, okay, I will push first index, first index element, I will push third index element. And when I will push, I will mark this as true. So suppose here I have marked that this is taken, right? Here I have marked that this is taken, right? First index element is taken. Here I have marked third index element is taken. Okay, I can't take it again. Okay, now let's complete this one. There is first I will complete the first one. Okay, so what I will do, okay, because I have taken first, so again I will start from it, right? Now I start from it, right? Let me remove this. Again I will start from it. I have taken I can't take 1 because that is already taken. This map will tell me, right? Remember, this map is going to tell me that you have taken 1, now you can't take it 1, right? So you can take either 2 or 3, right? You can take either 2 or 3. So let's suppose if I have taken 2. So what I will do, I will push that in my array, right? I will push that in my array. It will be 1 and 2, and my map will tell that you have taken the second index element. Taken the second index. Remember, I am telling second index element. Okay. So here I have pushed second index element. Okay. Now what I will do, once this is done, again I will complete this one, right? Again I will start, right? Again I will start from 0. Again remember, I will start from 0 in each iteration. This I will check, okay, this is already taken, I can't take it. Second index, first index, okay, sorry, this is not second index, this is first index, my bad. First index, okay. So this already taken, right? Now the only option is left with 3. So I will push 3, right? And I will push the last element. I will push 1, then 2, then 3. And my map will tell that you have pushed all the 3 elements. Okay. Right? You have taken first index, second index, and third index. Right. Now, if I move further, right? If I move further, that is the end of the loop, right? So what I will do, I will return. So I will return back to it. So I will return back to it. Remember, whenever basically here I am pushing the elements, right? I am pushing the elements, right? But when I will do here, when I will backtrack it, I will pop the element. I will pop the element, and also I will change. I will move to this state. Remember, this is one state. To move, I will mark this as false. So I will mark this as false. I will mark false my map, right? I will mark in my map that is false. So there was only one possibility that you can take, and I have taken it, right? So I will pop from here as well, right? I will pop this first index element also, right? So this is also popped, and I will mark this as a false, right? Now here, when I will come to this right? So I have taken this first, that is true. I have taken second path, right, with first index, that is also done. Okay, now I will choose this one. Suppose I'm not taking this one and I'm choosing the second index, right? So it will come here. Let me this diagram a bit of here so that it won't distort my graph, basically this tree, recursion tree. So what I will do, see, I have taken one, right? In this first function call, I have taken a call of 2. Now what I will do, I will take a call of 3. Okay. And my map will tell that you have taken the 0th index and you have taken the third index element. Okay. Again, what I will do, I will start a complete new loop, right? I will start a new loop. Okay. And I will check. Okay. Here, basically, I will check that can I take this one? No, taken it. Can I take this one? Yes, you can take it. Right. So what I will do, I will take that one. I will push that into my element. So I will say 1, then 3, then 2. And my map will tell that you have basically taken all the indexes element. That is true, that is true, that is true. Okay. Now what I will do, I will backtrack to my previous state. Whenever I will backtrack, I will pop it, I will pop the element, right? And I will mark this as false. Basically, you can see that was true. So I will mark this as false. Okay. Now this is also done, right? So what I will do, I will backtrack to my previous solution. I will pop and I will mark this as false. Now here I have explored all the possible options. So what I will do, I will backtrack to my previous previous state, right? Where I have marked all this as false. This was true, that was also false. Okay. Now what I will do, I will take the first index. 0th index element is done. I have pushed the 0th index, right? I have pushed then first index and I have pushed the last index. Okay. Now I am taking the second index, right? And pushed into my array. Remember, I am pushing it. I am not placing it. I am pushing it. So I have pushed this 2, right? I have already pushed. Now again the call will done. Okay. Again the call will done. I will check. Is 1 is done? Is 1 is pushed? This state will tell no, it's not done. So what I will say, let's take this one first. So I will take this one and my state will tell that now you have 0th index element and the first index element is done. Okay. So I will say yes, that is done. Okay. I put now again the same loop will start, right? Can I take this one? 1? No, that is true. Can I take 2? No, that is true. So can I take 3? Yes, it is. You can take it. So what I will do, I will take that one. So if I am going to take it, it will again, I will push it. I'll push it to 1, 3. This will put true, true, right? That you have pushed all the 3 elements, right? So basically, you can see in each state, I'm starting a loop, fresh loop. It is starting from 0. It is starting from 0, it is going to n. In each state, I am starting a loop that is starting from 0 to n. But I am not doing all the function calls. Why? Because of map. Because of this map. This map is telling that you have pushed 1. This is already done. So now you can't take it. Now you can't take it. Even I am starting with 0. Right? So this is done. What I will do, I will move back to my previous state by simply pop and mark false. And what I will do, I will move back to my previous state, simply mark it false, right? Now I will check in this state, right? in this state, I have explored this option, right? I have first put 2, right? Now again I have started a loop new and I have explored this option 2. This is true, right? So only the thing that is left, that is 3. So what I will do, I will try it with 3. Try with the last index. Okay. So let's suppose here it will be something like this. And what I will do, I will try with that one. So if I'm trying it, I will push 2, then 3, and my map will tell now you have pushed the second and the last. This is true and this is true. Again, a fresh loop will start, right? Again, a fresh loop will start. I will check. Okay, 2 I have pushed it, 3 I have pushed it. Okay, that means this is done. This is done. So the only left is this one. I will simply push it. My map will tell that you have pushed all the 3 elements. So 2, 3, okay, white, 2, 3, and 1. And my map will tell you have pushed 0th index, you have pushed first index, you have pushed last index. Okay, that is done. Okay, that is done. So what I will do, again I will backtrack from this solution. I will backtrack. And how I will backtrack, remember, tracking is popping out the last element that you have pushed, popping out the last element you have pushed, okay, and mark that true to false, right? This one, that true to false. Okay, I'm not marking it, I'm just making it blank so that you can understand it much more better. But this is what I am doing, right? Here also I will backtrack. And now the same thing we will do with this one, right? Okay, and then you can, I will some quickly complete this tree. So let me complete. So this will be my final recursion tree. Here you can see basically I'm choosing between 1, 2, 3. So 1 first, then pushing first one, then 2, then 3, right? Then now I pushed 1, right? Who is telling? My map is telling that I have pushed 1, right? Now the remaining 2 elements I have left 2 and 3. So I can take either 2 or 3, right? If I take 2, what is the last possibility that I can take? That is only 3. If I have taken 3, what is the last possibility that I can take? That is only 2. This is how I am solving it. Okay. Now let's quickly jump to the pseudo code, right? Basically how we are going to write the code of it, right? We can understand all this tree, but how we will code it out. So by the examples, right, you can check, right? I'm doing a loop, right? I am doing a loop, and that's a recursive loop. Basically, in each function call, I am starting a loop that is starting from 0 to n. Why I'm starting from 0 to n? Because I'm choosing between the n elements, right? I'm choosing between the n elements, right? And which to pick, which to not pick, which who is telling, this map is telling me that you can take either this one or leave them. Okay. So what I will do, I will start a loop that will start from 0 and it will go till n, right? So let's write quickly our pseudo code. So basically create GP, right? GP is basically generating permutations, right? So what I will do, I will take one data structure, or let's first define all my data structure before starting anything. So array, basically this, I put my answer. So I am starting an array, then taking one map. Map is also an array, okay, of this size. So I will say new array, that is nums. Basically nums is whatever the nums is provided, right? Nums dot length, I will fill it with false. So I will fill it with false. Okay. And I will have one answer output. So let's take a resultant equals to your output. Okay. Now I have one function that is GP. Inside this, I will pass this my list, that is array. Okay. And my nums, that is my array that is given array. Remember, that is a given array nums. Okay. That is a given array nums. Now what I will do, I will have one more map, basically this map, and that's it, right? Okay. Now, as I mentioned, on each function call, I will start a loop that will start from 0 and it will go till n. Okay. Go till, and what I will do, I will check how I will choose between the elements. I will check if map of I, okay, if map index, that is okay. So basically, if map of I is false, not false, true. So if this is true, that means if it is not filled, right? If it is not filled, then only I can take it. And how I will take it? I will simply say array dot push that index. element. Okay, so it will be nums of I. I will push it, and after pushing, I will map that index equals to true. I have pushed it. Okay. Then what I will do, again one function call that this is done. Okay. I will do the same function called array nums and map. No any indexes. And when I will come from it, right, this is now backtrack code. When I will come from this function, I will do pop. Okay, basically I'm going back to that state. I will do map of I equals to false. Okay, remember that is my backtrack code. Okay, this is my backtrack code. I will simply remove from it. Okay, basically this is done, right? This all these thing, right? All these four things will come under this loop, right? Then a for loop, and then this will end. I will simply call. Now there is a one base condition that is left. So what will be the base condition? You can check, right? Here, right? My base condition is when my array length is equals to my given length. When my array length is equals to my given nums length. So I will simply say, right? My base condition is whenever my array length that is completely zero at the starting, if it is equals to my nums dot length, what I will do, I will simply return from it, right? So before returning, you need to push your answers. So you will simply say rest dot push and your answer triple dot arr. Why? Because this will create a copy of it, new copy with a new reference object. Okay. Otherwise, if the same copy, so the array will be changed. Okay. And what I will do, I will simply return from there. Okay. This is how we can solve this problem. Okay. I will simply call this GP function with array, with nums, with my map, and I will return the rest. Okay. Rest is basically this output, resultant output. Now let's talk about what will the time complexity of this approach. Okay. So here the time complexity, and see how many permutations I am generating. 1, 2, 3, 4, 5, 6. Right? 6. 6 arrangements are there, and 6 is basically your n factorial. And n factorial is running how many times? N times, right? So this is running n times. Okay. And that is also not n times due to math. Okay. So that is also one case. Okay, but I am taking the overall, it will be big of n factorial into n. Okay. And what about the space complexity? So you are taking one array as an space, right? This is array, and you are taking this resultant. Basically, both these are for the output, and you are taking one map. Okay. So if I talk about how many spaces you will take, so again there are total there are six arrays that you have created, six arrays with three elements, with n elements, right? So again the space will be also n factor into n. Okay, basically this will be your space that you are creating it, right? Then also your map will also take, so map take n, right? Because there are only three elements, right? So that will also take. And yeah, this will be your space complexity, right? If I take the higher term here as well, it will be n factorial into n space complexity here. Okay, so that is the time complexity, that is the space complexity. We are done with this approach. Now here we are getting a very huge space complexity, and your interviewer might ask you to optimize this further, right? Okay, we don't this time complexity. Okay, also you can say that, right, this is your resultant. Basically you need to print the output, so you can ignore this n factorial n, but still we are getting this as an space, right? Because that is, we need to print it, right? So basically we need the output, right? So this two space will comes under the output, but this is the extra space that I am taking, right? So I will try to reduce this space. So what we will do, we will take one more approach to solve this problem. Okay. So now let's see how we can solve this problem. Okay. Now let's discuss the approach to without taking any extra space. Okay. So let's start. So let's see how we can we cannot take any space, right? How we can ignore that space? So basically we were taking map. Why? In order to check, right, if I have filled that element or not in that array. Okay. So why we need to take an array to fill it, right? Instead of this, you can see what is basically a permutation is. It's basically an arrangement, right? So the same array, right? If I swap them 1 and 3, okay, so it will be 2 will be here, and there will be 3, and here will be 1. Okay, so this is also one arrangement, right? If I swap, if I suppose if I swap them this 2 and 3, this 2 and 3, so I will get 3 here and 2 here. Okay, now this is also one possible arrangement. So in order to get the all permutations, right? In order to the all permutations, okay, what we can do, we just need to swap them sequentially one by one. Okay. So what I will do, I will try to swap them, suppose 1 with 2, right? Then I will try to suppose with 1 with 3. Then I will try to swap with 3 and 2. Right? This, like this, right? If I swap them and if I backtrack to the previous state, right? If I swap them sequentially, we can solve this without using any extra space map, right? Simply swapping, because swapping won't take any extra space, right? So we can do this problem. So let's try to solve this problem by using swap, right? Swap the elements, right? But we need to swap the elements in a sequential manner that we can get all the possible permutations. So now let's solve this by swapping them. So let's see here. Here we have in this given array. Let me put the indexes as well. And now we will swap them, right? So whenever we swap, right, we'll swap between two indexes, right? Two elements, we'll swap it, right? So let's take two pointers here, okay? And you can take any pointer's name, right? I'm not going to use the same pointer name in the code, but you can take either P or Q because it will give a reference here, okay? So this is my array, okay? And let's start. Suppose I will take one with the red pen, okay? And one is my yellow pointer, okay? Yeah, this pointer, because if I take the name here, right, it will create confusions. So see, right, I will start my, this pointer will move in this direction, right? Both the pointer will move in this direction. Both the pointer will move in direction, and I will swap them between the pointers. I will swap them between the pointers. But this pointer, right, the red one pointer will come start with the fresh position from a recursion call. Okay, let's see. Just be with me and let's see how I will do it. So suppose if I swap them between these two pointers, right? Two pointer indexes, right? So what will be that case? We use white. Okay. The array will be the same, right? Literally the same array elements, right? One will be here because if you swap one with one, nothing will change, right? If you swap one with one, nothing will change, right? So what now what will the position? The position will be same, right? Now your red pointer will come here, is pointing to, because that's a next function call, okay? And your yellow pointer will also come to here, right? Because it is also a next function call, okay? Now you can see why I have moved my both the pointers, because I want this to be fixed. I want this one to be fixed. Similarly, right? Suppose, okay, now my yellow pointer will move, right? And suppose if it is here, now what I will do, I will do a swap, right? So I will get all the three swaps here. Okay, let me put it right. So if I do a swap, okay, my bad. If I do a swap, right, here 0 and 1 indexes, right? 0 and 1 indexes, what will be the final array elements? It will be 2 will come here, 1 will come here, and it will be 3. Again, you can say because that's a next function call, so my pointer will come here and my yellow pointer will also come here. But you can see my yellow pointer is in a loop, right? It is simply swapping, it is moving in the indexes, right? And it is calling the swap function. It is moving, it is calling the index function. Okay. So now let's see the case 3, right? Okay. My yellow pointer will move ahead, right? And suppose if it take 2, second index, okay, and it will swap with the red one. So if I swap them, if I swap them, so 3 will come here, 1 will come here, 3, then 1, and here will be 2. And after a function call, my pointer will point to the last index, and my this pointer, my yellow pointer, will also point to here. Okay. Sorry, it won't point to here, right? Yellow pointer will always point to here. Why? Because see, my yellow pointer is pointing to here because that is fixed here, right? That is fixed here as well, right? This will also point to here because see, this position is fixed, right? So now we can, my yellow pointer can move in this direction only, right? From here to here, from here to here, from here to here. And again, we will apply the swap, right? So if I swap here, right, basically the same indexes, nothing will change here as well, right? It will be 1, then 2, then 3, right? Okay, but after the function call, my red pointer will come here and my yellow pointer will come here. Okay, so that is one function call we have done here. Okay. Now what I will do, after suppose if I swap 3 with 3, nothing will change here as well, right? Nothing will change here. My 1 will be here, 2 will be here, 3 will be here, right? And my pointers will be get out of the array, right? Out of the array. So you can see here I am swapping with the 0th index, right? I'm calling on the 0th index. Here I am calling in the first index, swapping with the first index. Okay. Here I am calling with the second index. Okay. So this is how it will work, right? Similarly, now basically this is done. Okay. Now you will get it. Once you have done this, right? You have swapped them, right? What you will do, you will backtrack to the previous state, right? You will back to the previous state. And when I am backtracking to the previous state, I will swap the elements with the same indexes, right? I will swap them with the same indexes. So I will come here, right? And from here, I will come to this position, right? So now see, right? My yellow pointer is taken this case 2. Now I have a chance of taking 3, right? I can swap with 3. So the next case will be, suppose if I am swapping with 3. So in that case, my array will be 1 is fixed. Okay, no is going to change. 2 and 3 will be swapped, right? Okay, 2 and 3 will be swapped. So basically it will be 1, and here my next pointer will come to here, right? Here, and my this pointer will come to here. Okay, but I will swap them. So if I swap 2 and 3, it will be 1, 3, comma 2. Okay, now if I swap this position, that is the only left, give me the same answer, that is 1, 3, 2. That is 1, then 3, then 2. Okay, that is one answer. Okay, now what I will do, I will backtrack from it. So if I am backtrack from it, okay, if I am backtrack from it, I will be at this position. And if I am backtracking of this, I will be at this position. But how I will be at this position? So again, I will do a swap. So you can see when you are doing a function call, you are swapping between these two, right? Basically now yellow pointer will come to here, right? You are swapping between these two. And when you are coming back, then also you are doing the swapping. Okay. So basically your one pointer is starting from 0, it is going to 2, right? Once this is fixed, it is starting from 1, it is going to 2. Once this is fixed, it is starting from 2 and remain 2 because that is the last element. Okay. Now from here, I will find out all the possibilities, right? So suppose if I'm swap 1 with 1, so it will be 2, 1, 3 only. It is 2, 1, 3. But after the function call, my red pointer will come to here and my yellow pointer will come to here. Okay. Now what I will do, okay, I will simply swap them. So again, if I swap them, right, nothing will change. The same thing will be there. 2 will be there, 1 will be there, 3 will be there. And my red pointer will simply out of the bound and my yellow pointer will also out of the bound. Okay. Now what I will do, okay, that was a function call. That was a function call. Function call. Let me put the arrays, rows. Okay. Now what I will do, I will backtrack to the previous state again by swapping. I will backtrack to the previous state again by swapping. So here I have explored this option, swapping with this one. Now I will explore this option. Now I am exploring this option, right? What I will do, I will simply swap them. So if I swap them, one case will be One case will be that 2 and I am swapping between 1 and 3, so it will be 3 1, right? And now what I will do, I will simply put here, okay, it will be 3 1, but how it will come, let's see. After this function call, my right pointer will here, right? You can see my pointer is moving 0th index, now 1 index, okay, in the second index, and from here it is going to the last. My pointer will be here, my yellow pointer will also be here, okay. And now if I swap them, right, nothing will change. It will be 2 3 and 1, okay, it will be 2 3 and 1. And now you can see what I will do, okay, both pointers are on the outside of it, okay. And what I will do, I will simply backtrack to the previous state, 3 1, and I will backtrack to the previous state. Remember, when I am backtracking it, right, I am doing a swap. I will always do a swap. So here I will do the swap, nothing will change. Here I will do the swap, right? This 1 and 3, 3 and 1 will become 1 and 3, right? So I will backtrack to the previous state, and this is how you will generate all the possible permutations. You can see one of the arrangement, 1 2 3, 1 3 2, 2 1 3, and 2 3 1. Let me complete this one also. So this will be the final recursion tree. So here you can see basically what I'm doing. I'm here as well, right? I'm swapping between these two, so it will be same, right? Then I will swap one with one, it will be the same, right? Now this position is explored. I can swap with the next one, right? So if I swap 2 and 1, it will be 3 1 2, right? Now if I swap the same index, it will be 2 and 2, and that's it. So basically, how you can say, right? You can come with this question, right? Okay, this I can understand, but how to code it, right? How we are going to code it. So let's understand our approach again, once again, by giving some variables. So suppose the red one, I am calling it's with the index, and the yellow one, I am calling it's with my I pointer. Okay. Again, very similar, index and I pointer. So you can see here, right? In each case, I here, let's talk about the first one. I is starting from 0, or I can say I is starting from the index, right? So I is basically starting from the index, right? And it is going till n here, okay. And now in the one function call, you can say your index is basically index plus 1. And again here I can also say my I is starting from the index. My I is starting from the index, it is going till n. Here also again, right, I can see my index is now index plus 1, right? Here in this call, I can say index plus 1, okay. And again, my I pointer is starting from the index and going till n. So you can see it is starting from 0, it is going till n. It is starting from index, it is going till n. It is starting from this index, it is going to n. So here 0 to n, here 1 to n, here 2 to n, and here this is done basically. So whenever I am simply starting my I pointer with index to n, and I am taking this index on each function call, I am incrementing it. So red one I am incrementing in each function call. You can see this function call index plus 1, this function call index plus 1, whatever the index is. This function call index plus 1, this function call index plus 1. So we got this thing that there will be one for loop that I will start from I, okay, that I will call with the index and it will go till, right? And whenever there is a function call, right, whenever there is a function call, I will do index plus 1. Okay. So now let's quickly understand the pseudo code, right? I'm going to write, and before that, let's check what will be the condition when I will return from it. So you can see this is the last case I'm getting return from it. So can I say when my index and my I, any one of them is out of the bound, I will return from it. So that will be our base case, right? That will be our base case. If I'm taking here index, I can simply say whenever my index is going to n, I will simply return from there. Okay. So now let's quickly constitute the pseudo code of this approach. So let's quickly write the pseudo code. So here what I will do, again I will start with in the starting, let me take one array, that is our output array, okay. And I will call, I have this function gp function basically generating permutation, and here I have the nums and the index, only these two things, okay. Now index you can remember with our red pointer index, okay. So let me put it with the red, so that, because here in this problem I have used colors to make you understand, so let's stick with that. Okay, so that is my that index that I have used. Okay, now what I will do in that inside this function, right, I will run a for loop. Remember, for loop where my I pointer, that's why I'm making it with yellow. My I pointer that is equals to index. Okay, I will start from index and it will go till n. So I less than, okay, my bad. So I less than equal less than simply nums dot length, or nums dot length I can simply write as n. So I go till n. Remember, I was saying the same thing. My I will start from index 2, right? So my I will start from index to n. I will do I plus plus. Okay. So this will be my for loop. Now what I will do, I will call this function. Okay. I will call this function with yellow color. I will call this function with the same nums. Okay. And the index plus one. Right. So what I will do, I will simply say index plus one. This is the index. Remember, this is the index that I'm calling about. Okay. Now before this, what I will do, I will swap them. Okay, because you can see I am always swapping between index and I. So I will swap them nums again index and I. Okay, and after from there, right, because that's a backtrack. So after from there, I will swap between index and I. Okay, again index. Let me take with the pen. So this is index and I, index and I. Okay, so I am swapping the index and I. Okay, once this is done, right, now let's do the our base condition. Whenever my index is equals to nums dot length, what I will do, I will simply stop there. Okay, so I will return from it. So you can simply say that rest dot simply rest dot push. Okay, whatever you have in your nums, I will push it because I need to find the answer. Okay, so why I'm doing this spread operator, because it will create a new object, new instance, right? Otherwise, if I simply push nums, my nums will get changed and eventually I will have nothing. Okay, now this function I will call with gp nums with 0, and in the last I will return res. Okay, so that's all. That's the only thing we need to do here, and basically this is will be our pseudocode. Okay. Now, what will the time complexity? Again, we are generating total n factorial permutations, right? N factorial arrangements, if I say. So, if I have n factorial and that is again, that is a loop that is going till n. So, I will say the time complexity will be same as n factorial into n. That is big O of n factorial into n, and space complexity is now reduced. Space complexity, I will say that is only n factorial. Okay, even in n factorial there will be n elements, but again this is for the output, this is for the rest. Okay, but that is in the output. So if I ignore that one, if I ignore this n factorial into n, because that is in the output, we need to do it, we need to take it. So if I ignore that, then there is no any space that I am taking. So that's why the space complexity will become big O of 1 if I am ignoring. Remember, if I am ignoring. Okay, the last you can make the swap. Swap is nothing. Basically, you have one array. Suppose you have I and j, right? So what you will do, you will say, let's suppose one temp will be your array I, and array I will be your array j, and your array j will be your temp. Okay, so that's a swap function. Okay, so I hope you are clear with both the approaches, approach 1 and approach 2, right? How basically these two approaches working. Okay, now in the next video I will give you a complete code implementation of all both these approaches. Okay, and then in the next video we'll check out one of the approach dry run. Okay, I hope I have make you clear basically how we are proceeding it with. Okay, you can create your own recursion tree and understand the same thing will happen, right? But I will give you one dry run of this approach too, so that you will some things clear basically how the swapping is happening. Okay, so discuss that in the dry run video. Till then, bye bye, see you in the next video.